Hi everyone, we're going to do 4.3a, the fundamental theorem of calculus. Okay, assume f is continuous. On some interval from a to b. So assume f is continuous on interval from a to b, then we integrate from a to b f of x dx, and that equals f of b minus f of a, where f is any antiderivative of f. Okay, that is f prime of x equals f of x. Okay, all right, so let's do an example. We've been working with this function, and I promised you I'd show you how it would work. And the function is f of x equals x squared plus 1. So we're going to mark this on the graph from 0 to 2. That's what we've been doing all along. F of 0, we put a 0 in there, is 1. F of 2 is 5. So let's pick one somewhere between 0 and 2. F of 1 is 2. Okay, so let's plot that. We've got 1, 2. I have to make these smaller to fit. 1, 2, 3, 4, 5. So it's not going to look quite what it's really supposed to. So f of 0 is 1. F of 2 is 5. And f of 1 is 2. All right. So we're going to integrate that, and in doing so, we're going to find the area under the curve. Put a big A for area. Okay, so we're going to use the fundamental theorem of calculus to do that. I'm going to erase this part right here so we can do that now and fit it so you can see it on the graph. Okay, so we're going to say let f capital of x equal the integral of x squared plus 1 dx. Okay, which we know would be the area in the problem we're working with. Well, what would we do if we were just asked to integrate this? Well, we would add 1 to the 2 and get 3, and then we would multiply by its reciprocal. All right, then this is just plus 1x. All right, so now let's actually do it. We're going to integrate from 0 to 2 of x squared plus 1 dx. All right, now according to the fundamental theorem of calculus, we're going to go f of b minus f of a. Well, here's f of x right here. So we're going to go f of b, which is f of 2, minus f of a, which is 0. So we're going to take this function and put a 2 in it. So we get 1/3 2 cubed plus 2 minus, don't forget those brackets when you have your minuses, 0 over 3 plus 0. Okay, so here we have 8/3. 2 cubed is 8. 8/3 plus 2. And we can change that to, put it into thirds if we want. Multiply this by 3, and we get 6. Okay, so we have 14/3 3 goes into 14 4 times with 2 left over. 4 2/3. Just like I showed you in a couple videos ago. All right, let's continue. We're going to be using the fundamental theorem of calculus to do lots of problems. So here's some examples we're going to do. Oh, before we do that, I wanted to show you a standard way of writing this, because that's what I'll be doing. So let's say we're given this same problem. The standard way we would do this is we integrate this first. We add 1, divide by that number, plus x. And then to state that we're going from 0 to 2, this is how she puts it in the book. I actually was taught just one line. We go from 0 to 2. Okay? So this is how we go from here to here, and then we do the other thing, which is we split this up and we put the 2 in there. So we put 2 in there, 2 cubed over 3 plus 2 minus, and then we put the 0 in there plus 0. And go from there, which we know is 4 2/3. So that's the exact area under the curve from 0 to 2. Okay, so let's do another problem. We're going to integrate from 1 to 2 x cubed dx. Okay, it's my dog trying to get in here. Move over. No, come on. Okay, so what we do is we integrate x3. We add 1 to the 3 and get 4. And we're going to divide. Actually, we're multiplying by the reciprocal, which is the same thing, dividing by 4. Okay, and then what are we going to do with that? We're going to do that from 1 to 2. Okay, so that means we're going to put a 2 in there, and we're going to minus and put a 1 in there. Okay, so we have 16 over 4 minus 1/4, which equals 15 over 4. John, move over. Okay, which equals 3 3/4. Okay, move over, honey. Go on. Okay, so let's go on to the next problem. Yes, you're a good boy. He always likes rewards when he goes potty outside. He's a good boy. Okay, let's do another problem. Okay, we're going to go from 0 to 4. John, move. Go on. Okay, from 0 to 4, let's go ahead and change this square root to 1/2 exponent. Okay, and then from here, we're going to integrate this. Now remember, to integrate this, we add 1. So adding 1, we get 3/2. And then we multiply by the reciprocal, 2/3. Now you're wondering, why don't we write plus c? Well, when we have parameters, we don't write plus c. Okay? So now from here, what we're doing is we are saying from 0 to 4. Okay? So we're going to put a 4 in the first one, 2/3, 4 to 3/2, minus 2/3, 0 to 3/2. And I love it when it's 0. It's so easy. We just get rid of that, right? Okay, so let's do this one. We have 2/3. This is the square root of 4, if you want to think of it that way. You can think of it this way, 4 to 1/2 to 3, because if we multiply 3 times 1/2, we get 3/3. So here I square root 4, and we get 2/3, 2 cubed. Okay, this becomes 8. So we have 2/3 times 8, which is 16/3. And that reduces down to 5 1/3. Okay? Now, in the last examples, we've been getting 0 right here, and it just goes away. But that doesn't always happen. I'm going to give you an example where that doesn't happen. So be cautious when you're doing this. It doesn't always work that way. So here's an example. We're going to go from 0 to 2 of 2e to the x dx. Now, a side note, if we go over here and we say y equals 2e to the x, we know y prime is also 2e to the x. So if we're going to integrate, it's going to be the same thing. So integrating, we get the same thing. And this only happens when there's a constant next to e to the x and we have just a 1 with the x. That way we're not taking the derivative of x, we just get 1. So that's why it works out. Okay, so doing that, we're going to go from 0 to 2. Okay, so we're going to put a 2 in there. We get 2e squared. And then we're going to minus 2e to the 0. Now 2e squared is just going to, we're going to factor out these 2's. We get e squared minus e to the 0. Okay, what is e to the 0 though? Right? E squared, e to the 0 is 1. So you just can't assume that because you have a 0 it's going to go away. All right. Let's do another problem. Okay, so I'm going to remind you. Recall f of x equals ln of x. And we said f prime of x equals 1 over x. Okay, so let's do this next example. And then I'm going to cut this tape short because the next one's going to take longer. I've got to make a big graph for you. So after this problem, we'll just stop and make another video. Okay, so this is 3 over x from 1 to 4 dx. So let's take out the 3, 1 to 4, 1 over x dx. Okay. Now remember, we're integrating, and we're going from 1 to 4, so x is not going to be less than 0. So we can go ahead, we're going to put our 3 here, and then this becomes ln of x, and the ln of x is from 1 to 4. Okay, now you can keep the 3 out and do your calculations. So we have ln of 4 minus ln of 1. All right. ln of 4, now what is ln of 1? ln of 1 happens to be 0. So we're just going to minus 0. All right, so the answer is going to be 3 ln of 4. Okay, but something interesting. I noticed in the book, they gave this same example, and they got a different answer. And you go, how can that be? How can you get a different answer? So I'm going to show you. In the book, 3 ln of 4, which is our answer, and this is what the book answer is, 6 ln of 2. Well, how can that be? Well, notice this. I figured this out. I'm all, oh, I get it. 4 can be 2 squared, right? And then, by the property, we can bring the 2 over here. So we have 3 times 2, ln of 2, which equals 6 ln of 2. Mystery solved.